What's the tea, honeybee? Welcome to class 5 of Unit 4, Graphs of Lines, Redux. So the idea today, we're revisiting everything that we've done thus far in Unit 4. We want to make sure that we have a really firm grasp on it before we move on. Now, today's video is optional. You are welcome not to watch. You've got a problem set to complete for me. However, if you find yourself in a position as you're working on your problem set, or even before where you're like, I'd like to see a little bit more of this before I give it another shot, here's your opportunity to follow along with me as we do some more practice problems together. I'm not going to tell you when to stop. I'm just going to keep going. However, I would strongly encourage you before each problem, pause the video, give yourself a little bit of time, work it out on your own, and then come back together once you feel like you've got something. Alrighty. So, taking our skills that we've seen thus far, one thing that we figured out was, well, if I want to determine whether or not something is an ordered pair of, or whether or not an ordered pair, is a solution of an equation or an inequality. Well, the idea behind my strategy, of course, to determine whether or not something is a solution, all I've got to do is substitute. Now remember, in my ordered pair notation, the first thing is the value of x and the second thing is the value of y. So every time that I see x, in this case, I'm going to replace it with the value of 0. Every time that I see y, I'm going to replace it with the value of -2 equals 18. If it's a solution, just going to make my equation true. -5 times 0, of course, is 0, so I can ignore this term. -9 times -2 is 18. Is 18 equal to 18? Sure is. This is a solution. For -3, -1, let's see. Well, I'm going to take -5 times -3 minus 9 times -1 equals 18. Again, in ordered pair notation, I'm in alphabetical order. So the -3 is taking the x spot, the -1 is taking the y spot. -5 times -3 is 15. -9 times -1 is +9. 15 plus 9, well, that is equal to 24. 24 is not equal to 18. No, this is not a solution. 4, 0. Again, 4 is going to be my value of x. So I'm going to take 4 and sub it in for x. I'm going to take 0 and sub it in for y. And I want to see, is this less than or equal to -2? 8 times 4 is 32. -3 times 0 is 0, so I can functionally ignore this guy. 32 is not less than or equal to -2, so no, this is not a solution. And finally, -5, -7. So, -5, I'm going to slot into my x position. -3 times -7, less than or equal to -2. 8 times -5 is -40. -3 times -7 is +21. If I add those two things together, -40 plus 21 is -19. -19 is less than or equal to -2. This statement is true. The values do in fact give me a solution. Cool. Next up, let's say that I want to graph a line in standard form. 4x plus 3y equals -12. If you want to pause, here's your chance. So knowing that I've got something in standard form, remember my 3-step strategy. First move is to build a chart. So I'm going to give myself some values of x and y on my line. I could, of course, guess and check, but the idea is if I algebraically substitute in values, then I should be able to more easily identify some solutions to my linear equation. So, easiest place to start is by finding our intercepts. So I'm going to start by plugging in x for 0, and then I'll plug in 0 for y. So every time I see x, I'm going to replace it with 0, and I'm going to solve for y. Well, 4 times 0 is 0, so that just leaves me with 3y is equal to -12. Divide both sides by 3 to isolate our variable y. Y is equal to -4. So if x equals 0 and y equals -4, that tells me the point 0, -4 is on my graph. 0, -4, well, the 0 for x tells me I'm moving 0 units to the left or right. Negative 4, I'm moving 4 units down. So that would be 1, 2, 3. Negative 4 is right here. And I'm going to label my point 0, comma, negative 4. Now that I've plugged in 0 for x, again, next easiest move, quality of life choice, let's plug in 0 for y. So plugging in 0 for y, I would say that 4x plus 3 times 0 is equal to negative 12. 3 times 0 is 0, so that guy goes away. I'm just left with 4x equals negative 12. Divide both sides by 4 to get x by itself, and x is equal to negative 3. This tells me that the ordered pair, negative 3 comma 0, lives on my graph. So I'm moving negative 3 units on the x-axis, so I am 3 units over to the left, 0 units up or down. Here is my point, negative 3 comma 0. And then again, last thing I need one more point as a little fail-safe, a little check. So to check my work here, I'm going to choose ideally a nice value of either x or y to plug in. Let's plug in for y for diversity's sake. Let's say that I want to plug in something like 2. So I'll plug in 2. Doesn't really matter what number I choose. Plugging in 2 for y, I'm going to say that 4x plus 3 times 2 is equal to negative 12. All I need to do now is solve for x. Well, 4x plus 6 is equal to negative 12, minus 6 from both sides. That tells me that 4x is equal to negative 12 minus 6, which is negative 18. Divide both sides by 4 to get x by itself, and x is equal to negative 18 over 4, which reduces to negative 9 over 2. So that tells me that the point negative 9 over 2, comma 2 is on my graph. Well, negative 9 over 2, that would be equivalent to negative 4.5. Negative 4.5 is between negative 4 and negative 5 on the x-axis. And then on the y-axis, I need to go up 1, 2. So negative 4.5 comma 2 would be right over here. Now that I've got my 3 points, all I need to do is connect them with a line. So I'm going to draw, as best as I can, the straight line that passes through all 3 of these points. Include my arrowheads on my graph to indicate that it extends beyond the graph. Last thing I need, let's label my axes as x and y. There we go. There's the graph of 4x plus 3y equals negative 12. And again, my advice to you is always to start by finding the intercepts, but you do not need to. You can plug in any values for either x or y that you want. Cool. Let's do another. X minus 2y equals 7. So, same idea. I probably want to start by finding some values of x and y. Easiest way to do so is by using a chart. So I'm going to make myself a table for my values, give myself a column for my x, a column for my y, and a column in the middle for my connector tissue. All I've got to do now, easiest place to start, let's find what happens when x is 0. So plugging in 0 for x, I get 0 minus 2y equals 7. Well, 0 minus 2y, I can functionally ignore this guy. That's the same as negative 2y equals 7. Divide both sides by negative 2 to get y by itself. Y is equal to negative 7 halves. This tells me that the point 0, comma, negative 7 over 2 is on my graph. So I'm moving 0 units to the left or right, and on the y-axis, 7 over 2, so this is equivalent to negative 3.5. So I'm going to count 1, 2, 3. It would be between negative 3 and negative 4 on the y-axis. So here is my point, 0, comma, negative 7 over 2. Cool. Now that I've found my y-intercept, let's find our x-intercept. So I'm going to plug in 0 for y. X minus 2 times 0 equals 7. Negative 2 times 0 is just 0, so I'm left with x equals 7. Well, would you look at that? I've already found the value of my variable. So when X is 7, y is 0. The point 7, 0 lives on my graph. It's on the x-axis. All I need to do is count 1, 2, 3, 4, 5, 6, 7 units over to the right. So here's my point, 7, 0. And finally, let's find one more point as our fail-safe. Can plug in anything that we want for either x or y. We plugged in for y last time. Let's choose a nice number. Maybe I'll say 1 for x. So plugging in 1 for x, I know that 1 minus 2y is equal to 7. All I need to do is solve for y. So I'll start by subtracting 1 from both sides. That tells me that negative 2y is equal to 6. Divide both sides by negative 2. Y is equal to negative 3. So that tells me that the point 1, negative 3 lives on my graph. That point is right here. So I've got 1, negative 3. I've labeled all 3 of my points. I will connect them with a straight line, or as close to straight as I can manage. Include my arrowheads to indicate it keeps going. Label my x and y axes. And I'm happy. There's the graph of x minus 2y equals 7. Cool. Next up, let's say that I want to graph some funky lines. 4/3 y equals negative 3. Negative 8x equals negative 28. Well, when I just see a variable of y, I of course know that my graph is going to be a horizontal line. I'm saying that the y values need to be the same, so the elevation above the x-axis needs to be the same. The x-coordinate can be whatever it wants, but the y value must always be whatever it is. But in order to get there, remember I need to get y by itself. So if I want to get y by itself, well, I need to get rid of 4/3. One way to eliminate 4/3 is to multiply by the reciprocal of 3/4. When I do this, this would tell me that y is equal to negative 3 times 3/4. If I think of this like a fraction to multiply, this would be negative 9 over 4. Cool. So the graph of y equals negative 9 over 4, it's a horizontal line through the y-axis at negative 9 over 4. So I'll label my y-axis and my x-axis. Negative 9/4. So this number is approximately negative 2.25. In fact, it is exactly negative 2.25. So it's going to be between 1, 2, there you go. Between negative 2 and negative 3, it's a little bit closer to our negative 2. I'll draw the horizontal line through that value. There you go. There's your graph of y equals negative 9/4. Next up, so I've got negative 8x is equal to negative 28. Again, when I just see x in my equation, I know this guy is going to be a vertical line. So I've got a vertical line. The x value must always be the same, which means the y value, how far up or down we can go, can be whatever it wants. But if I'm always passing through the same x value, all of those points are going to line up to give me a vertical line. So all I've got to do is find out what the value of x actually is. Well, to do that, let's divide by negative 8. When I do that, x is equal to negative 28 over negative 8. Both of these numbers are divisible by 4. Negative divided by a negative is a positive. So this would leave me with 7 over 2. So on the x-axis, 7 over 2. So we said this is 3.5 earlier. So 1, 2, 3, 4. It's going to be in the middle of 3 and 4. So I'm going to draw a vertical line through the middle of 3 and 4 on my x-axis. There you go. There's the graph of x equals 7 over 2. Nice. Let's find some intercepts. So abstractly, say I want to find the x-intercept and the y-intercept of each of my lines, and I want to write those as ordered pairs. Well, again, to find the x-intercept, I need to plug in 0 for y. And to find the x-intercept, or the y-intercept, sorry, I need to plug in 0 for x. If I live on the x-axis, I have not gone up or down, so y is equal to 0. If I live on the y-axis, I have not gone left or right, so x is equal to 0. So all I've got to do, right, if I want to find my x-intercept, often abbreviated as xint. For 2x minus 5y equals negative 10, again, I'm going to plug in y equals 0. So for my x-intercept, I would say 2x minus 5 times y is going to equal 0 equals negative 10. For my y-intercept, again, here it's the reverse. If I want to be on the y-axis, then x needs to be equal to 0. So I'm just going to solve the equation 2 times 0 minus 5y equals negative 10. Here, negative 5 times 0 is 0. 2x is equal to negative 10. X is going to be equal to negative 10 divided by 2, which is negative 5. So if x equals negative 5, that tells me that the point negative 5 for x and 0 for y lives on my graph. There's our x-intercept. Our y-intercept happens when x equals 0. 2 times 0 is 0. Negative 5y is equal to negative 10. Divide both sides by negative 5 to get y by itself. We find that y is equal to 2. So if y equals 2, that tells me that when x is 0, y is 2. The point 0, 2 lives on my graph. Nice. 3x minus y equals 4. So again, to find my x-intercept, what do I do? Well, if I'm on the x-axis, that means that the value of y has to be 0. So I'm going to take 3x minus 0 for y equals 4. 3x minus 0 is 3x. 3x equals 4. We're going to divide both sides by 3. That means x is equal to 4/3. So that tells me x equals 4/3. And of course, to get the x-intercept, we said y has to be 0. There's our ordered pair. And finally, for our y-intercept, again, to find the y-intercept, I plug in 0 for x. So this is going to become 3 times 0 minus y equals 4. Well, 3 times 0 is 0, so I know that negative y is equal to 4. If negative y is equal to positive 4, I want positive y by itself, so flip both of my signs. Positive y is equal to negative 4. So that tells me when x equals 0, y is equal to negative 4. There's my ordered pair. Fantastic. Let's do some slope, and then we'll call it a day. I lied. We're going to do standard form first. Sorry. Negative 6x plus 2 parentheses 1 minus 3y equals 5x minus 13y. So you'll hopefully remember standard form is ax plus by equals c. I don't know if you can hear the cop car outside. They're coming for me. They know what I've done. Negative 6x plus 2 parentheses 1 minus 3y. Well, I can simplify these parentheses. Again, my goal is to get all of my variable stuff over to one side and all of my number stuff over to the other. So all of the x's and y's need to be on the same side, and the number needs to be by itself on the other. Cool. Negative 6x plus 2 minus 6y is the simplified side on the left. And now again, I want to get all of the x's and y's to the right side, and all of the number stuff over to the left. Or other side, whatever, it doesn't matter. So let's start by subtracting 5x from both sides. When I do that, that gives me negative 11x plus 2 minus 6y equals, right, these go away, negative 13y. Again, I'm trying to get all of the y's over to the left, so I'm going to add 13y to both sides. When I do that, right, just to be consistent with my notation, maybe I'll draw another line up there. Doesn't really matter. So when I do that, I get negative 11x plus 2 plus 13 minus 6 is 7y. Negative 13y plus 13y is 0. Last thing I've got to do is subtract the 2 so that all of the number stuff goes over to the other side. That leaves me with negative 11x plus 7y equals negative 2. There is the standard form of this linear equation. Fantastic. Now let's do some slope. So I've given you two graphs. I want you to find the slope of each line. So we have a slope formula, But more easily, remember that slope, often represented by the symbol m, is defined or represented or algebraically calculated, however you want to think of it, as rise over run. And I know that slope is constant, so all I need to do is find any 2 points on my line. So looking at my line on the left, it looks like I've got a nice point over here. Looks like I've got a nice point over there. To calculate slope, all I need to do is figure out the rise, in other words, how much I go up or down. This here is 1 grid unit. And then my run, how much I go left or right to get back to that point. So I'm counting 3 units over to the right. My slope here is going to be a rise of 1 over a run of 3. Last thing I need to do, is this line increasing or decreasing? Well, if I take my finger and trace along it from left to right, my finger moves down the graph. So the slope here needs to be negative. This line has a negative slope. Negative 1/3 is its slope. And for the one on the right, here again, just need to find a couple points. So looking at my graph, it looks like I've got a nice point actually here on my origin, and then I've got another nice point kind of over here. So if I find my rise, so I go up 1, 2, 3, 4. So my rise is 4, and my run, I count over 1, 2, 3. So my slope here is going to be my rise of 4 over my run of 3. In this case, my line, if I trace along it from left to right, my finger moves up. This line is increasing. It has a positive slope. So positive 4/3 as written is just fine. Cool. Let's do some more abstract ones. So I want to find the slope of a line through the points -9, -1, and -30, 5. So in order to do this, I need to use my slope formula. Remember the slope formula? Well, it's defined as the difference of the y-coordinates of my 2 points over the difference of my x-coordinates of my 2 points. y2 minus y1 over x2 minus x1. All I've got to do if I want to use this formula is figure out which point do I want to be the first one. By convention, I often say that the one on the left is the first point, so that will be my x1 and y1. The one on the right is usually my second point, so that'll be my x2 and y2, but you can flip the order. As we've seen in class, it does not matter. So, slotting everything into my slope formula, y2 I've identified as 5, minus y1 I've identified as -1, divided by x2, which is -30, minus x1, which we've identified as -9. 5 minus -1, well, that's the same as 5 plus 1. -30 minus -9, well, that's the same as -30 plus 9. 5 plus 1 is equal to 6. -30 plus 9, well, that's -21. And then all I need to do is simplify my fraction. Notice that 6 and 21 both have a common factor of 3. That leaves me with 2 in the numerator and 7 in the denominator. My slope is going to be -2/7. Cool. Let's do it with 2 more tables, and then we'll call it a day. Here, we're assuming that all of these points live on a line. Again, I'm going to use any 2 points because my slope is constant. My strategy is often to pick the numbers that are the smallest. So looking at my chart, it looks like this point and this point are going to give me the smallest, nicest, easiest numbers to work with, but I could use any combination and I would be good. So let's say that I choose this point here at the top to be my x1 and my y1. I'll choose this guy at the bottom to be my x2 and my y2. So substituting into my formula, slope is equal to y2 minus y1 over x2 minus x1. Substituting in, y2 here is going to be 3 minus y1, which is 8, divided by x2, which is -8, minus x1, which is 0. 3 minus 8 is -5. -8 minus 0 is -8. But negative 5 over negative 8, I can simplify to 5/8. This is my slope. And finally, for the one on the right, doesn't really matter which one I choose here. Something's going to be wonky, maybe you've already noticed. Let's say here I took the first and the last one there. Maybe I'll take the middle two here. Again, it doesn't really matter, but plugging into my slope formula, I'm going to say this guy is x1, this guy's y1, this one's x2, this guy's y2. So I know that my slope, m, is going to be equal to y2 minus y1 over x2 minus x1. All I need to do now is substitute. So y2 we've identified as negative 5 minus y1 is negative 8 over x2, which is negative 6, minus x1, which is also negative 6. Again, working with my negative signs, negative 5 minus negative 8 is the same as plus 8. Negative 6 minus negative 6, that's the same as plus 6. Negative 5 plus 8, well, that's 3. Negative 6 plus 6, that's 0. Anything divided by 0 is, of course, undefined. So my slope is undefined. And if I have an undefined slope, what again does that tell me about my line? Well, lines with undefined slope, they can go up and down, but they cannot go left or right. Their run is 0, so this is a vertical line through, in fact, the x value of negative 6. So x equals negative 6 would, in fact, be the equation of this line. Alrighty, my dears, thank you for joining me for some extra math practice. Good luck on your problem set. Not like you need it. You're amazing. Or are you? Alrighty, take care, be good. I'll see you when I see you. Goodbye.